Algebra 2 Common Core. So this is the first video of this next unit, and we're covering sequences, series, and summation here. We have two videos on sequences, and the first one we're talking about is explicit sequences. So there's really two major types of explicit sequences that we're going to work with, and they are called arithmetic and geometric. And these terms are a little confusing, but it's very helpful to remember that an arithmetic sequence is nothing more than a linear sequence. And a geometric sequence is nothing more than an exponential sequence. I really can't tell you why we don't just use linear and exponential, why we use the terms arithmetic and geometric, but we do. So arithmetic is linear, geometric is exponential. And if you remember the difference between these, like what an arithmetic sequence was when we did, looking at a table, how could you tell it was linear? And what you could look as the y values if it's going up by a constant rate. So if it's like plus 5, plus 5, plus 5. If it has a constant difference, then it's a linear sequence, in this case also known as arithmetic. If it's going up by, instead of a plus 5, plus 5, plus 5, instead of it's going up by like a times 5, times 5, times 5 type of rate, then that would be an exponential or geometric. So those are really the two different things here. Is we have a common difference d, that to go from one term to the next, it's plus or minus a constant difference d, and we use the letter d for that, for a common difference. For a geometric, it's times r. We get from one term to the next by multiplying by, so this one is really more of a sum difference type of thing, and this is a multiplication type of sequence. That's what linear and exponential things are. So number one, what is the common difference of the arithmetic sequence? So I tell you it's arithmetic, but you could always figure that out looking at 5, 8, 11, 14. What's the pattern? How do I move from one to the next? And the common difference, d, we can always get by doing any term minus the previous term. Now, a lot of times it's pretty obvious here, and I think in this case it's probably pretty obvious that we're doing plus 3 from one term to the next, plus 3, one term to the next, plus 3. But if it's not obvious, you could take any term, like I could take the 11 and subtract it from the term before, 8. 11 minus 8 is 3. So here your common difference is 3, and that's all this is asking for, is what is the common difference? How do I get from one term to the next? And so in this case, d would equal 3. But any term minus the one before it is how we can get there. So looking at the pattern below, what will be the 10th term? So you need to determine if this is arithmetic or geometric. And, again, is it linear or exponential? Am I getting from one term to the next by adding something, or is it multiplying? And you could test it out, like, all right, well, from 3 to 10, that would be plus 7. Is that also the case from 10 to 17? Yes, it is, plus 7, plus 7. So this is clearly a linear arithmetic sequence. Now, if I want to know the 10th term, yes, I could just continue the pattern. But we have an explicit formula also over here that gives us a shortcut. And so let me write this down for this question here, that a to the n, which is basically a form of saying kind of any term, is a1 plus n minus 1 times d. That's what we have here, a1 plus n minus 1 times d. So now what do each of these things mean? Well, a sub n is really how we say this, a sub 1, a sub n, a sub 1. I call this like the first term, the second term, the third term, and so on. Well, the symbol for that would be a sub 1, a sub 2, a sub 3, a sub 4. And so a sub n stands for the nth term, where a sub 3 is the third term. So a sub 10 is the nth term, like really any term, can be found if you have the first term, a sub 1 is the first term. N minus 1, n represents what term you're working with, and d is that common difference, how are we getting from one term to the next. So in this case, the 10th term, this would be set up like this. The 10th term would be a sub 10 equals the first term in the sequence is 3 plus n minus 1, because I'm doing a sub 10, I want the 10th term, n equals 10, minus 1 times d, and d is the common difference. How are we going from one term to the next? Well, that's that plus 7. So it's a positive 7. And so just by looking at this, I got two important things. I knew the first term was 3, and the pattern, the common difference, was 7. And so I just simplify this out here. This is 10 minus 1 is 9 times 7 plus 3. So 9 minus 7 is 63 plus 3 is 66. Base of 10, 3 plus 63 equals 66. All right, so that's using the explicit arithmetic linear formula. First term plus n minus 1 times d. Number 3 wants to know what is the common ratio of the geometric sequence. The common ratio, r, instead of d. So we reserve difference for d. And that's a linear thing. We use r for rate, because rate is a concept of multiplication. That's our exponential geometric. So what is the common ratio of a geometric sequence? So this is an exponential sequence. And so basically, how am I going from one to the next? It's not going to be plus or minus something. It's going to be times something. So how do I go from -2 to 4? I need to multiply by -2. And then I need to multiply by -2 and multiply by -2. So in this case, r equals -2. Now I mentioned over here that I can get any difference term by doing any term minus the previous. Well, for a geometric, I can get r by doing any term, not minus the previous, but divided by the previous term. So if I take any term here, like the -8, and I divide it by the one before it, 4, it divides out to be -2. Again, in this case, it was kind of obvious, but we're going to see problems where it's not. Like number 4. What is the 15th term of this geometric sequence? All right, well, for the 15th term, we need the explicit formula, which we have over here. We have an a sub n arithmetic and an a sub n explicit. And here, the arithmetic was the first term plus n minus 1 times d. Well, this is the first term times r raised to n minus 1. And this should look familiar. This is your exponential format. You know, principal times some base raised to an exponent. That's exactly what an exponential formula looks like. And this is a linear formula, too. I mean, this is basically your y equals mx plus b. Except it's kind of backwards. This would be like your b plus mx in a sense, you know, where your difference here, your d is your slope. That's why it's linear. But here r is the base, and so that's a rate. So anyways, so let me rewrite this explicit formula over here for the geometric. A sub n is a1 times r raised to the n minus 1. And so again, this would be a sub 15. So a sub 15. So I need a sub 1, which is just the first term. They tell me we're starting off with negative rad 5. And then I need r. So how do I get from one term to the next? How do I go from negative rad 5 to rad 10? See, here it was kind of obvious. At least I thought it was. -2 times -2 is 4 times -2 times -2. Right? It's doubling, but it's changing signs, so it's -2. How do I go from negative rad 5 to negative rad 10? Well, it may not be obvious, but I know I can figure that out by doing any term divided by the previous. And so any term, I'll take the rad 10. Let me do this over here a little bit. So any term, rad 10, divided by the previous negative rad 5. And what does this simplify to? Well, I can do a radical divided by a radical. Because a positive divided by a negative is negative. And rad 10 divided by rad 5 is rad 2. So my r here is negative rad 2 times negative rad 2 times negative rad 2. That's how we get from one to the next. So that's my r, negative rad 2. And raised to the n minus 1 for 15 would be raising it to the 15 minus 1, or 14, right? 15 minus 1 is 14. And then what does this come out to be? Well, I could, kind of figure this out. I could certainly use a little bit of calculator help here. Let's see, let me type in, first we always want to type these things in separately, because I think that rad 5 is going to probably stay rad 5, but let me see what negative rad 2, so let's do open parentheses, negative radical 2, close that parentheses, so I should get out of there. Let me change this a little bit. First get out of the radical, then close the parentheses, and raise it to the 14th. Now, I know it's going to be positive because a negative raised to an even exponent is going to be positive, and it works out to be 128. So this is 128 positive times negative rad 5. Well, positive times a negative is a negative, and it's just going to be 128 rad 5. So negative 128 rad 5. And I could type this whole thing in and get a decimal approximation and see that this is the same thing if I wanted to kind of guess and check my way through it that way. Um, and that's really, about it. So like I said, I could do more examples here, but let me save the rest of them for classwork. So these are your two main explicit formulas you need for the start of this chapter. Arithmetic, but remember that's just linear. Geometric, which is exponential. These formulas you need to know. You need to know them well. And with practice, you will start to remember them, but we have a common difference or a common ratio, and that's how you can tell which it is. You can get any term minus the previous for difference, any term divided by previous for ratio, and just kind of use the formula. And we're going to have a good amount of practice with this. And then we're going to use these for quite a few things going forward. And our next video will be recursive sequences, which is kind of like, all right, how could I turn this into a formula for if I have one term, how do I get to the next? So it's very much related, but we'll talk about that in the next video. See ya. See ya.